Welcome to this video on solving a system of equations by substitution. There are three ways to solve a system of equations. You can use graphical methods, substitution, or elimination, which is also called addition. In this video, we will be examining the method of substitution. Recall that when we learned to solve equations graphically, we found three possibilities. One possibility is that there is no solution, which looks like two parallel lines. Since parallel lines never meet, or because they meet at infinity, we say that they have no solution. They have no points in common. We can also have two lines which have infinite solutions. This happens when we're given two different equations, which, when we do a little bit of work and rearranging, or when we graph both of them, end up being the exact same line. The last case is where we have exactly one solution. So we have two lines, maybe looking something like that meet at exactly one point, and we can identify that ordered pair, so we can solve for x and y. So when we use the process of substitution or elimination, when we use either algebraic approach, we also can get no solution, we can get exactly one solution, or we can get infinitely many solutions. Again, substitution as well as elimination or addition are different ways to achieve the same result. We're doing the exact same thing, and we should get the same answer whether we solve a system of equations graphically or using one of the algebraic methods. So let's look at this chart. As you can see, the first column here shows a graph of two parallel lines, which of course have no solution. But what if I wanted to use an algebraic method? What would that look like algebraically? Well, algebraically, if I solved a system that had no solution, I would obtain something that is clearly untrue. For example, if I ended up with something that said 0 equals negative 4. It's very clear that 0 and negative 4 are not the same number. There's no way, there are no values of x and y that are going to make 0 equal to negative 4. So since there is no way to make this true, we say that there is no solution. So again, if I'm solving graphically and I get no solution, that means I have parallel lines. If I'm solving algebraically and there's no solution, that means that I have a mathematically false statement that cannot be made true. If I have exactly one solution, as you know, that means that the lines meet at exactly one point on a graph, and algebraically, it's exactly as you would imagine. You can solve the system of equations and you find a value for x and a value for y. Nothing really interesting going on there. In the last case, we could have infinitely many solutions. Graphically, that means that we actually have the same line that's being graphed twice, right on top of itself. Algebraically, what's going to happen is that we're going to get something that is always mathematically true. For example, 0 equals 0. 0 is going to equal 0, regardless of what x and y equal. So what we say is that there's infinitely many solutions because there are infinitely many values of x and y for which 0 is equal to 0. Again, it's always true. There's not really anything you can do to make it false. So again, even when we're using these algebraic approaches, we still have three distinct possibilities. We have no solution, exactly one solution, or infinitely many solutions. So let's think about the word substitution, because that's the method we're exploring in this video. What does the word substitution mean? Where does it get its name? Well, a substitute, as I'm sure you know, is a replacement for something. For example, if you have a substitute teacher, it's not the normal teacher that you would see every single day. So, likewise, in this method, we substitute one part of an equation into the variable of another equation. So here are the basic 4 steps that we're going to follow when we use substitution. First, we pick one equation and isolate one variable in that equation. Notice that two different people could choose two different equations or two different variables and still get the correct result. So there's more than one correct way to solve a system of equations. Please keep that in mind. Next, we substitute the expression that we, on the other side of the variable that we isolated, and we put that into the second equation, and we solve for a variable. Then we substitute this answer into one of the original equations and find the second variable. And then, last but not least, we have to check our work with the equation that we did not use in step 3. Alright, example number 1, we have 2x minus 3y equals 7, and we have y equals 3x minus 7. So first we need to isolate one variable. So look at these equations and see if you can find out if a variable has already been isolated for us. If you said that this y variable in the second equation had already been isolated, then you are correct. So again, we don't really need to do step 1 in this problem because it's already been done for us. Let's not reinvent the wheel. So what we're going to do is we're going to substitute the expression 3x minus 7 into the other equation and solve it. So what do I mean by that? Well, the other equation is 2x minus 3y equals 7. So the substitution property of equality says that wherever I see y, because y is equal to 3x minus 7, I can stop writing y and I can start writing 3x minus 7, because according to that statement, y is the same as 3x minus 7. So notice everything else came down, okay? The only thing that changed or that transformed was the y. Everything else, everything else stayed exactly the same as it was. Okay, again, I substituted the expression 3x minus 7 in place of y. Why did I do that? Because y is the same as 3x minus 7. From here, it's just a matter of doing some algebra. So, as you can imagine, I need to do the distributive property here. Negative 3 times 3x is negative 9x. Negative 3 times negative 7 is positive 21. Again, I'm using colors to indicate what is changing versus what is staying the same. Also, remember, it's always a good idea to draw that line through your equal sign so that you don't get the two sides of your equation confused. So we have 2x minus 9x. We can combine those since they are like terms on the same side of the equation. So that becomes negative 7x plus 21 equals 7. Now, again, we're just trying to solve, right? We're still on step 2 right here. That's where we are. Okay, so we're trying to isolate our variable. We're solving for x. So the negative 7x comes down. Negative 7x equals negative 14. I can divide both sides by negative 7, and I get x equals 2. Okay, so it looks like we've done a lot of work, guys, but we've really only done steps 1 and 2. One way to know that you're not quite finished yet is if you look at your answers, or the possible solutions. We don't have no solution, we don't have infinite solutions. We have one solution at blank blank. Well, guess what? We only have one value right now. We only have the x value. We still have to do some work and solve for the y. Okay, so we can pick either equation, it does not matter. I myself personally am going to choose the equation that looks easier to me, and the shorter, easier equation to find y, from my perspective, is y equals 3x minus 7. Okay, so we just found that x is equal to 2. So let's put 2 in place of x, and then find out what that gives us for y. So 3 times 2 is 6. 6 minus 7 is negative 1. So we get y equals negative 1. Now, just take a minute and step back and look at all the work we just did. As you can see, we just did a lot of work, right? The more steps there are, the higher the probability, because we're human, that I made a mistake somewhere. And it happens all the time, even to me, and I've been doing this for years. Okay, so the most important thing here is to take a minute and check your work. Now, it's also important to understand that you can't use either equation. You have to use the equation that we didn't use in step 3. So let's just stand back for a second and label our steps. Okay, so this is step 1 here, right? We already found an equation where the variable had already been isolated, so that was step 1. Okay, so this is step 2 right here. We substituted and solved for x. Okay, so then this is step 3 here where we're finding the other variable. So the equation I used in step 3 is right here, 3x minus 7. So I can't use 3x minus 7 again. I have to use the other equation, which is 2x minus 3y, 3y equals 7. I have to use this other equation. Okay? So we found that x is 2, and we found out that y is negative 1. Okay? So 2 times 2 is 4. negative 3 times negative 1 is positive 3. Okay, 4 plus 3 is 7. So we end up with a statement that says 7 equals 7. Okay, so again, I kind of ran out of room here, but this is step 4, where I checked my work. Okay, and again, because I got a mathematically true statement, it checks out, and I can be confident that the solution really is 2, negative 1, or x equals 2, y equals negative 1. Okay, let's do another problem. In this problem, we have 3x plus 2y equals 1, and x minus 5y equals 6. So first we have to find one equation and isolate a variable. So I want to encourage you to pause this video and figure out which variable is almost already all by itself. Which one is the easiest to isolate? You can pick either equation and either variable in either equation. If you said it's easiest to isolate this variable right here, then you are correct. So let's label our steps here. So here is step 1. I'm going to isolate this variable. So I start out with x minus 5y equals 6, and by simply adding 5y to both sides, I get x is equal to 5y plus 6. So now I have successfully isolated one of my variables. So I'm done with step 1. So now I can move on to step 2. So step 2 asks me to take this expression, 5y plus 6, and put it in place of x in the other equation. Well, the other equation is 3x plus 2y equals 1. Okay, so again, wherever I see x, I'm not going to write x anymore. I'm going to write, in parentheses, 5y plus 6. So we have 3 times the quantity 5y plus 6 plus 2y equals 1. Again, x is equal to 5y plus 6. So wherever I see x, I can write 5y plus 6. So now I can go ahead and use my distributive property. I get 15y plus 18 plus 2y equals 1. 15y and 2y are like terms. So we have 17y plus 18 equals 1. We can subtract 18 from both sides. We get 17y equals negative 17. We can divide both sides by 17, and we find out that y equals negative 1. So remember, all of that was just step 2. Again, if we come over here, we can see that we're probably going to have one solution, and x is negative 1, but again, we're only halfway done because we still have to find our other variable. We still have to find, in this case, y. So let's look at step 3. Okay? Remember, in step 3, you can use either either equation. It doesn't matter. I, myself personally, am going to choose to use this equation. If you'd like to use a different equation, you are welcome to do that. Okay, so we found out here that y was equal to negative 1. Hopefully that's correct. So I'll put negative 1 in place of y. So negative 5 times negative 1 is positive 5. So I have something plus 5 equals 6. So I can just subtract 5 from both sides, and I find that x equals 1. Okay, and again, I just encourage you guys to remember the very most important step of this is to check your work. Okay, you can tell just by looking at the screen we've done a lot of steps, right? And again, the more work you do, the higher the probability that you miss something or forget something. Okay, so again, we've done step 1, step 2, and step 3. Again, we can't pick which equation we use in step 4. We could use either equation in step 3, but in step 4 we have to use the other equation. So in step 3 we use the equation x minus 5y equals 6. So we've already used this equation, so we have to use the other equation. We have to use 3x plus 2y equals 1. We don't have a choice this time. Okay, so we said that x is positive 1, and we said that y is negative 1. So let's see if we are correct. So 3 times 1 is 3, 2 times negative 1 is negative 2. And in fact, we are correct. 1 equals 1. That means that is a mathematically true statement. So, it looks like I wrote this in the wrong spot. That's a very easy mistake to make. So in this case, x is 1, so the 1 should go here, and y is negative 1, so the negative 1 should go here. So our final answer is that we have one solution at 1, negative 1. Example 3. Remember, our first step is to choose one equation and isolate one variable in that equation. You have different options here, so you can choose any one that you want. For me, I'm going to choose the equation x minus y equals negative 1, and I am going to choose to add y to both sides so that I have x equals y minus 1. Remember, you may make a different decision. You may pick a different variable or a different equation. That's absolutely okay. You should still get the same answer. In fact, if you want to pause this video, work it out in a different way that I'm approaching it, and then come back and unpause it and see if you get the same solution, you can prove that to yourself. Okay, so we've accomplished step 1. So now we need step 2. Remember, step 2 is to substitute this expression here, y minus 1, into the other equation anywhere we see x. So the other equation is x plus y equals 5. So again, wherever I see x, I'm not going to write x anymore. I'm going to write y minus 1. Okay, in this case, you can use the parentheses. You don't actually need them in this particular problem. So I have y minus 1 plus y equals 5. So I essentially have 1y plus 1y. That gives me 2y minus 1 equals 5. I can then add 1 to both sides of the equation. We get 2y is equal to 6. If we divide both sides by 2, we find that y equals 3. So again, it looks like that we have one solution, and it looks like so far our y is going to be equal to 3. So again, remember, we've only done steps 1 and 2. We still have to do step 3 and step 4. So I'm going to draw a line here just to give myself more room. So for step 3, I need to use either equation, it doesn't matter which one, to find the other variable. I've already found y, so I need to find x. So let's just pick the first equation, x plus y equals 5. And again, we just found that y equals 3, so we're going to write 3 in place of y. So I have x plus 3 equals 5. I'm going to subtract 3 from both sides, and I get x equals 2. Okay? But before I leave, I want to check my work by substituting these two values, x equals 2 and y equals 3, into the other equation. Remember, it says use the equation you did not use in step 3. Well, what equation were we using in step 3? Well, in step 3, we used the equation x plus y equals 5, right here. So we can't use that equation again. We have to use the other equation, which is x minus y equals negative 1. And we said that x is equal to 2, and we said that y is equal to 3. So let's test and see if that is in fact true. So we have 2 minus 3, that's negative 1. So we get negative 1 is equal to negative 1. So sure enough, that is the correct answer. Let's look at number 4. Here we have y plus 4 equals 3x, and then we have 2y minus 6x equals negative 8. So first we have to isolate one variable. I'm going to choose to isolate the y in the first equation. I'm going to do this by subtracting 4 from both sides. So we have y is equal to 3x minus 4. In step 2, I'm going to use the other equation, which is 2y minus 6x equals negative 8. And wherever I see a y, instead of writing a y, I'm going to write 3x minus 4. And I'm just going to bring down the whole rest of the equation. Again, the only thing that changed was the y value. So now we can distribute this 2 here. So that gives us 6x minus 8. And again, just bring down everything else. minus 6x equals negative 8. So we have a 6x minus 6x, and if you want, you can take an extra step and rewrite it. Just rearrange your terms before you combine them. 6x minus 6x is equal to 0x. So we have 0x minus 8 is equal to negative 8. Well, I don't need to write that. I can just write negative 8 is equal to negative 8. Well, what are we supposed to do here? We didn't find x or y. In fact, this statement, negative 8 equals negative 8, is kind of ridiculous, right? Like that's saying, like, I am me. Red is red, blue is blue. It's really not giving you any information at all. However, it is a mathematically true statement, right? So it's always going to be true no matter what you have for x and y. So we said when we get a mathematically true statement like this, where it's true for any value of x and y, we have what are called infinite solutions, right? Because it's always true. So in this problem, we did step 1 and 2, but we really can't do steps 3 and 4. And the reason that we can't do them is because there's nowhere else to go. Some students ask me and they're concerned, they're like, well, how can I check my work? And in this case, all you could really do would be to go over the work that you did and just, look at every step and make sure, verify that your math is correct. Because we don't have any values for x and y that we can substitute back into one of the equations. So that would be the best way to check your work if you really need to or want to. Okay, let's keep going. So let's look at example 5. So again, we want to choose one equation and isolate one variable from that equation. That's always our first step. So you can choose either equation or variable. I'm going to choose negative 2x plus y equals 5. I chose that because the y doesn't have a coefficient, or really more accurately has a coefficient of 1. So it's the easiest to isolate. So we get rid of these, so we have y is equal to 2x plus 5, or you could say y equals 5 plus 2x, it doesn't matter. So then, in step 2, I can take the other equation, 6x minus 3y equals 9, and I can take the y in this equation, and wherever I see the y, I can write in place of it 2x plus 5. Okay, and again, I'm just bringing down the rest of the equation around there. So then I'm going to distribute this negative 3. That becomes negative 6x minus 15. Again, bring the rest of the equation down. Okay, 6x minus 6x is 0x. So we have 0x minus 15 is equal to 9, or negative 15 equals 9. Okay, so what do we do with a statement like negative 15 equals 9? Okay, so is this true or is this false? Well, this is false, right? There are no values of x and y that can possibly make this true. So there's no way to make this true, so that means there is no solution. Okay, and again, just like in the last problem, we were able to do step 1 and step 2. We can't really do step 3 or step 4. And once again, if you really want to check your work, you could go back and look at your algebra step by step and look at each step and make sure that you didn't make a mistake or do anything wrong. That's really the only way to check this, because you don't have a value for x or for y that you can substitute back into your original equation. Okay, let's do one more example. So you might have noticed at the bottom of the last screen I had written intentionally make a mistake. So that's what I want to do here, is I want to intentionally make a mistake so that you can see what it looks like when I check my work and I am incorrect. Okay, so I'll try to make a mistake towards the end so that you still have some good good data to work with. Okay, so first I need to choose one equation and isolate one variable. This is really totally up to you. I'm going to try to avoid fractions here, but I think I'll pick negative 2x plus 4y equals 12, and I think I'll isolate the x. So I will do that by first subtracting 4y from both sides. Wait a minute. So I bring down the negative 2x equals negative 4y plus 12. Okay, and then we have to divide everything here by negative 2. So that becomes x is equal to 2y minus 6. Okay, so that was a lot of work, and that's only step 1. So far I have not made, as far as I know, any mistakes. I have not made any deliberate mistakes. Okay, so we just used this equation, so now we need to use the other equation. The other equation is 5x minus 6y equals negative 14. Okay, and of course what we want to do is wherever we see x in this equation, in place of x we are going to write 2y minus 6. Okay, and just like in previous problems, we will distribute. So 5 times 2y is 10y, 5 times negative 6 is negative 30, minus 6y equals negative 14. Okay, I'm going to combine these, so I have 10 minus 6 is 4y minus 30 equals negative 14. Okay, kind of running out of room here, so I'm going to move to the other side. So I have 4y minus 30 equals negative 14. Okay, then I'm going to add 30 to both sides. That gives me 4y equals 16. Divide by 4, I get y equals 4. Okay, now I promised you at some point I was going to make a mistake, okay, because I want you guys to see what that would look like. Okay, so you and I both know that, as far as I know, the correct answer is 4. Let's just pretend I dropped a sign somewhere and I said that the answer was negative 4. Okay, so now we've done step 1 and step 2. Okay, so now we're on to step 3 again. I built in an error so you can see what happens and what this looks like when we go to check our answer and our answer is wrong. Okay, so I can pick either one of these equations. In this particular example, to check my work, it doesn't matter. So I'm going to pick the equation negative 2x plus 4y equals 12. And I'm going to have to use another piece of paper. So let's see. We have negative 2x plus 4y equals 12. Okay, and again, we know that the answer is y equals 4. I'm going to put in y equals negative 4 for y, and then see what we get for x. Okay, so we have negative 2x minus 16 equals 12. Okay, and then what we can do is we can add 16 to both sides. Okay, so we get negative 2x is equal to 28. We can divide both sides by negative 2, and we get x equals negative 14. Okay, again, I'm going to put an asterisk by this because this is probably the wrong answer, right? Y equals negative 4, x equals negative 14. Okay, but we still need to do step 4. Remember, step 4 is to check our work, okay? And we need to check our work using the equation that we did not use over here. Okay, so again, in step 3, this is step 3, we use the equation negative 2x plus 4y equals 12. So now we have to use the equation 5x minus 6y equals negative 14. Okay, so let's see what happens when we put the wrong answers in here. Okay, so we have x is equal to negative 14 and y is equal to negative 4. So I'll just bring down the equation around those numbers. So 5 times negative 14, well, I think that is negative 70. Negative 6 times negative 4 is positive 24. Okay, and just looking at that already, I can tell you that that is not going to give us the correct answer, but just for the sake of being thorough, I'll go ahead and do the math for you. So this is going to be negative 46. Okay, so you have something that looks like negative 46 times, negative 46 equals negative 14, which is false. Okay, so this is where sometimes students get confused. Okay, if we had gotten a statement like this in step 2, right, that would mean that there is no solution. Okay, when we get a statement like this in step 4, okay, at the very last when we're checking our work, this means that we made an error, okay, and that means that we have to go back and redo or recheck our work. Okay, so, and of course, as you know, I made the error intentionally by making the answer here y equals -4 instead of y equals 4. Okay, so let's pretend I went through, I checked all my steps, and I caught my mistake. So I was like, aha, y equals 4. So then what would I do? I fixed that mistake. Well, then I have to fix this other mistake, right? Because the mistake carried on right here. So what I'd have to do is I'd have to write a +4 here, and this becomes +4. And then, of course, since this is a +16, I'd have to subtract 16 from both sides. And we can bring down our -2x equals -4. We can divide both sides by -2, and lo and behold, we find out that x is not -14, but x is +2. So then what do? Well, then I need to go ahead and recheck this with my new answers. So let's erase this and try to check these new answers. So my new answers, again, are x is +2 and y was +4. So let's see if this works. So 5 times 2 minus 6 times 4 maybe equals -14. So this is 10 minus 24. Okay, so we would get -14 equals -14, right? So that means that that I am correct, okay? And so my final answer is x equals 2, y equals 4. Again, you can write it as an ordered pair, or you can just write it as x equals 2, y equals 4. Either of those are perfectly acceptable and would be correct. Okay, so be careful, guys. When you get a mathematically true statement in step 4, it does not mean you have infinite solutions. It just means you did everything right. When you have a mathematically true statement in step 2, it does mean you have infinite solutions. Okay. Likewise, if you have a mathematically false statement in step 4, it doesn't mean there's no solution. It means you did something wrong. You have to go back and check your work. When you have a mathematically false statement in step 2, that means there is no solution and there's nothing more you can do. So be careful. Okay, be careful with that, and practice identifying. Well, is this step 2? Is this step 4? Am I checking my work, or am I still just starting to find x and y? So please visit my office hours if I can help you any more.